Hello students, I hope you all are doing well. In today's session, we will discuss how to apply the stiffness method for frames. In the last few sessions, we have discussed how to apply the stiffness method, how to develop the stiffness matrix and how to analyze the beams. Right, in today's class we will start with the frames and we will solve one type of a frame here. This is the non-sway frame and I hope you have understood in each of your unit we have solved first of all the beams, then we shift towards the frames, and in the frames you have two categories, sway frames and non-sway frames. So I am solving the non-sway frame here and I will give you one more question in the assignment part, and I request all of you to solve the variety of problems on this topic. That will give you a better confidence and you will able to solve multiple choice question with all the concepts from this part. Okay, so let's start. The question says we have to analyze a portal frame loaded and supported and shown in figure using the stiffness method, right? And if we are applying the stiffness method, we all know that whatever frame they have provided us, we have to first of all give the restraint to it. All the supports of your frames has to be restrained. They has to be restrained first of all, and then at a time you will give a unit rotation at each of the joints. Okay, now here we first of all go for the determining the degree of kinematic indeterminacy dki, which is equals to 0, 1, and theta b is representing the degree of kinematic indeterminacy at joint B. Now how the degree of kinematic indeterminacy is 1, that is a part of discussion, but we have already understood that, we have discussed that in the unit number 1. Okay, kinematic indeterminacy talks about the displacement taking place into your frames or your beam, and if we look at our frame, if we look at carefully at this frame, it has a 4 joint. At D you have 1 joint, at A, then at B and at C. So we have total 4 joints. Out of these 4 joints, A joint, C joint and D joint are fixed. Those were the fixed joints, and if they are fixed, they can't displace from it because they have restraint for any kind of rotation as well as displacement. Horizontal, vertical displacement as well as rotation is restrained at this place, right? And therefore since we have provided the restraint condition at this 3 of the places A, C and D, they cannot show any kind of a rotation or displacement, right? And that's why we left with only the support B here, where you might have a chances of rotation, because if there are a symmetry and if there is a certain loading conditions which we observe, then we can say that theta b will be a place where kinematic degree of indeterminacy can be occurred, and therefore theta b has been considered as a degree of kinematic indeterminacy. Now in the last class when we have analyzed a beam, you must have observed, or you must have understood one thing, that if the number of unknowns are 1, the matrix develops, stiffness matrix develops is of 1 by 1 order. If the number of unknowns are 2 or number of unknowns are 3, then matrix will develop 2 by 2 or 3 by 3 respectively. So how many number of unknowns, or how many number of, or what is a degree of kinematic indeterminacy defines the size of our stiffness matrix, right? Then next part, once we calculate the theta, we are going for coordinate directions to the unknown displacement. Now see, when I am saying I am analyzing the displacement taking place at B, then I will remove all the forces. I have not drawn that diagram, but I will draw it here like this. This end is fixed, this is also fixed, and this one is also fixed, right? And here you have a displacement, right? And that is where we called ATL. That is what we called ATL actually. Then this is what we called as assigning the coordinate direction to the unknown displacement. I have assumed one unknown, which is that theta b Now that theta b is what? Angle of rotation, and that is rotation. If the rotation is assumed as an unknown, then I have to decide. Priorly I have to go with certain direction, and we will check the direction which we have priorly assumed is correct or not, right? And that is why I have assumed all the forces has been removed, only the structure has kept with the unknown rotation taking place at theta, taking place at B support, right? And I have assumed the direction of it as an anti-clockwise, and I named it as ADL, right? Once you do that, the next step is determine the force developed in each of the coordinate directions of a fully restrained structure. Now, as we all know, in the stiffness method, whatever force or whatever beams or frames we are dealing with, we have to restrain all the forces, all the supports into it, and at a time we'll allow only one support to get a displace. Okay. Now ADL1. When we allow only one unit displacement at particular support, we will analyze the movement taking place at it. See, we adding these moments MFBA, MFBC, MFBD, because as we know we are calculating ADL here. ADL will be a summation of all the movements taking place at the B support. Now these movements will be a fixed end movements, and those are occurring like this. See, at this B joint, BA moment MF BA, then MF BD, and MF BC, right? So these summation of these three moments will give me a understanding of my ADL, give me an intensity of my ADL. MFAB, let's see once more. MFAB has a concentrated load, but it is eccentrically, it is actually placed, not eccentrical, it is placed, yeah, it is exactly at the center of your span, and it is 1 meter and 1 meter, it divides our beam into 1 meter span. Okay, divides equally into half part. Yeah, and that is why the MFBA value becomes minus WL by 8. We are using just a standard formula. We are doing it since first unit, and I hope you are habitual with it. MFBC is WL square by 12 plus MFBD is 0, right? So WL by 8 minus 4 minus 40 into 2 divided by 8, and WL square by 12 is 20 into L. L is a 4 meter here, so 4 square by 12 minus 40 into 2 divided by 8, that is first term. This is second term. Analyze it, use your calcium, it will be a 16.67. Yes. Now in the next step, you are supposed to determine the stiffness matrix by giving the unit displacement, by allowing a unit displacement. So here S11 will occur, S11 will occur. Now the question is, why only S11? See, if I give a unit rotation here like this, anti-clockwise and anti-clockwise direction, if I say theta b is a 1 unit displacement I have provided at theta b, then you have to check its effect at support A, at support C, and at support D. But you can see that support A, C and D are the fixed supports. They are fixed supports, and if they are fixed supports, they will not allow a rotation, and if the rotation is not taking place, theta will be automatically becomes 0, no rotation, no theta. And if theta is not occurring, if that is not a case, then even if you consider the effect of rotation taking place at B on A, C and D respectively, it won't be helpful, because there is no you have not allowed a rotation there will not be a unknown. Okay, so here only the S11 takes place. S11 will come from 3 of the sides. Three of the spans will contribute it, and how does it contribute? Both the far ends are fixed, therefore the value of coefficient of stiffness matrix S11 will be 4 EI by L from AB span, 4 EI by L from BC span, and 4 EI by L from B to D span. Add it, put the values of L into numerator and find the final answer. S11 is equals to 4 EI. Okay, that is our coefficient of stiffness matrix. Now at B, at joint B, there was no external couple acting at it, no external force is acting at it, and therefore force matrix becomes 0. It becomes 0. ADL1 is ADL we have calculated earlier, that is, yes, we have calculated here, that value is 16.67, and we have a stiffness matrix value which is 4 EI. We have calculated it here. The stiffness matrix value is 4 EI, and D is theta B. D is displacement matrix. Displacement matrix talks about the unknown displacement into your system, and that is theta B. Therefore theta B is equals to minus 4 EI minus 4.17 divided by EI. Okay, so that is a value of theta, and now put this value of theta B equals to minus 4.17 EI into moment deflection equation. Now you have to go for the moment equations. How do you are going for it? Moment equations. Moment equation which is made out with the help of slope deflection equation. Slope deflection equation will help you. You know how to develop a slope deflection equation. MFAB is equals to MFAB 4 EI by L theta A 4 if we can write like this, yes, MAB is equals to MFAB plus 4 EI by L plus 2 EI by L minus plus or minus 6 EI by L square, that will be a term, and that is what your slope deflection equation. Now you are supposed to write the slope deflection equation for each of the span, and then in that put the theta value equals to minus 4.17. Put in that theta value minus 4.17. Here now the question is, why my theta B come up with the minus sign? You have to pay attention that a sign or a rotation, unit rotation theta B I have considered in the anti-clockwise direction, that is wrong. The theta B is occurring or taking place into clockwise direction, and if we take it clockwise, then the theta B value only remains as a 4.17. Accordingly, you develop the equations for moment from a moment AB, moment BA, moment BC. You develop all the equations and then put the theta value as a 4.17, where theta A, theta D and theta C will be 0. Why it is 0? See here, our frame was like this, right? It was fixed, it was also fixed, and it was a fixed. So theta A, theta D and theta C will be 0 because those were the fixed ends. And does fixed ends allow a rotation? No, fixed ends doesn't allow rotation, and if rotation is restrained, will be there a development of theta A? Theta A will be 0, theta B will be also 0, and theta C will also be 0. Only the unknown here is B. Here with this we have ended we are done with our complete syllabus of essay. I want you to write down each and every lectures note into your book, which I have already instructed you to do so. I want you to write down the assignments on each of the unit. I have gave you a assignment. Today we have done with the stiffness method of analysis, and I will provide you an assignment on it. write it down and send it as a part of submission. Thank you so much.